All right, so in week one of distance learning here, we are going to start off with a little bit of a review of what we did before the break, looking at areas of parallelograms and triangles. So we had a few vocab words we saw in this one: base of a parallelogram, height of a parallelogram, base of a triangle, height of a triangle. So the first thing we'll see is the area addition postulate. Basically, this just means that the area of a region is the sum of the areas of its non-overlapping parts. So if pieces are not overlapping, then you include them in the area. If they are overlapping, then you omit one of them, but not both. So area of a parallelogram here, the area A of a parallelogram is the product of the base B and its corresponding height H. So you have the base B on there in the image, and then the pink dotted line is your height. So sometimes we might be missing a part, so we might have to find what those parts are if we are missing them. So this first one, we just want to find the perimeter and the area of parallelogram ORSTU. And again, we are missing the height here, so we do have enough to find the perimeter, so let's go ahead and do that first. So the perimeter for any of these parallelograms, you can use 2 times side 1 plus 2 times side 2. You got two sides that are congruent on opposite sides, right? So the 20 is also over there for ST, and the 32 is also on the bottom here. So now that we know that, we can just plug those numbers in. 2 times 32 and 2 times 20. Doesn't really matter which one's which. 2 times 32 is 64. And 2 times 20 is 40. And you add those up, and our perimeter is 104. Yeah, 104 inches. It's perimeter, not area. So it's just the unit we already are using. So now for area, we are missing a piece. We don't have our height, so we need to find that. We do have a right triangle here that we can use. So from our height down to the base, there's a right triangle. So what I'm going to do is take that triangle and move it down. Leave that 20 up there though. So we are missing this height here. So our height, we're going to use Pythagorean theorem. So height squared plus 12 squared is equal to 20 squared. So 12 squared is 144. 20 squared is 400. So we subtract 144 from both sides. And our height squared is 256, which is a perfect square for our height of 16. And we do have a unit, inches. We don't really need it there, but it's important to always keep your units around. So now we're ready to go and find our area. The area of our parallelogram. I like to use the symbol for parallelogram because we will get to polygons later on, of general polygons. And so our area here is base times height. Our base is 32. Our height is 16. So the area of our parallelogram is 32 times 16, which is 512 square inches. So our next one, again, we're missing the height, but now we have a 45-degree angle, so we can use our special right triangles, 45, 45, 90 triangle. So let me draw that out. So this is a 45, 45, 90 triangle. So we know when we have the hypotenuse, which we do here, it's 9. If that is our x, then the two sides are going to be x square root 2 over 2 and x square root 2 over 2. If it's the other way around, and we just have these as our x, the hypotenuse is x square root 2. So what we need to do here is use the first of our two triangles there. Our x is 9. So that means that our height is equal to x square root 2 over 2, or 9 square root 2 over 2. So we can simplify that and do 4.5 square root 2 over 2. It doesn't really matter. So we're going to leave it like that for now. So now we're going to find, we just have to find the area, no perimeter for this one. So we have our base, that's 12. And we now have our height, 9 square root 2 over 2. So that's going to be base times height, or 12 times 9 square root 2 over 2. So the nice thing here is that we have a 12 times a 1/2, basically, right? So that's 6. So it's going to be 6 times 9 square root 2. And 6 times 9 is 54. So the area of the parallelogram is 54 square root 2 units squared. It doesn't tell us if we need to get our exact answer or a rounded answer, so we can leave it just like that. Or we can go ahead and actually get the rounded answer, plugging that in the calculator. So if we use the calculator for that, it rounds, let's say to the nearest tenth, to 76.4 units squared. So now the area congruence postulate, if two figures are congruent, then they have the same area. Just throw that in there anyway. It's pretty basic, common knowledge. I would hope that if two things are the same, then they should have the same area. So here we have a triangle. So the thing about triangles is they're basically half of a parallelogram. If I take that triangle and I put it on top of itself, lining the two sides of the same with each other, then you make a parallelogram. So you take the area of a parallelogram and divide it by 2, and that's the area for a triangle. So base times height divided by 2. So let's take a look at a problem with that. So this one here, we have our height, we have our base, so we're good there. We have all the sides, so we can find our perimeter. So we're really set, but we are asked to do more than that. So you need to buy enough boards to make the frame for a triangular sandbox, or of the triangular sandbox shown, and enough sand to fill it. If one board is 3 feet long and one bag of sand fills 9 square feet of the box, how many boards and bags do you need to buy? So what we need to do, once we figure out what the area and perimeter are, we need to divide those by the respective numbers. So area is going to be the 9 square feet. We divide it by 9, we'll figure out the number of bags we need. The perimeter, we divide by the 3 feet long boards, and it'll tell us we have to round up, because you can't just buy a portion of a board, or bag for that matter. So we'll just have to round up for both of them, regardless of what the decimal is. So find the perimeter first. It's pretty easy because we have all three sides. We just add them up. 12 plus 16 plus 7.5. So the perimeter comes out to be 35.5 feet. So now, for bags, or for boards, sorry, we take our 35.5 feet and divide it by 3 feet. And that will tell us, so what we're doing is dividing this by feet per board. And in that process, the feet are going to cancel. We'll be left with just boards. So that will give us a nice rounded number, if we want to round it, of 11.83. And again, we can't buy a fraction of a board. Some stores will let you do that, but we need to buy 12 boards. Typically it's with molding for around the baseboards or things like that they'll let you buy portions of them, but not all the time. So now we need to figure out the bag situation. So we need to find our area of our triangle. So that's going to be base times height divided by 2. Our base here is 12. We can ignore the dotted part of the base because we don't need that. But the 9 is our height. And it's divided by 2. So 12 times 9 divided by 2. It's going to be 108 divided by 2, or 54 square feet. So now we need to take that to figure out the number of bags. So again, we have 54 feet squared. We need to use 9 square foot bags again, that cancels out the square foot. We're left with bags. It looks like it's on the bottom, but when you divide by a fraction, it flips. And so that's a nice even number. It's 6 bags. So we have to buy 12 boards and 6 bags to build this sandbox. So this last problem, the height of a triangle is 7 inches more than the base. The area of the triangle is 60 square inches. We need to find the base and the height. So we are missing the pieces, but we do have the whole. So what we need to do is just work backwards. So we know that the height is 7 inches more. So that means if we take the height and we set it equal to the base plus 7, that's a true statement, right? If we add 7 inches to the base, it's now equal to the height. And now our area is 60, and that's equal to base times height divided by 2. So now what we want to do is take this height formula and plug it in for the height in our area formula. So that's going to be 60 equal to base times base plus 7 divided by 2. So we're going to solve this for the b. We need to first multiply by 2 on both sides to get rid of the fraction situation. So we now have 120 equal to, and we can go ahead and distribute the b on top as well. Kill 2 birds with 1 step. So b times b is b squared, and b times 7 is 7b. So now we need to move that 120 over. So we're going to subtract it from both sides. So we have 0 equal to b squared plus 7b minus 120. So now we have a quadratic, so we got to go back and use our Algebra 1 skills. So we need to factor this. So the 120 is negative, so we need to do 1 positive and 1 negative. The 7's positive, so the larger number is going to be with the positive. So we need to figure out some factors of 120 and figure out what they subtract to be equal to. So obviously 120 and 1, right? So 120 minus 1 is 119. That's definitely not the 7 we need it to be. So 60 minus 2, right? Just having the first one doubling the second one gets us 58. We're getting smaller, which is what we need, but not nearly small enough, right? So keep going. Divide by 2 again. 30 minus 4 is 26. Divide by 2 again. 15 minus 8. That's 7. That's the one we needed. So 15 goes in our first blank. 8 goes in our second blank. So now we need to take our two factors and set them equal to 0. So b plus 15 equal to 0, and b minus 8 equal to 0. So we subtract 15 from both sides for the first one. Add 8 to both sides for the second one. So b is equal to a negative 15, or b is equal to a positive 8. Again, we're talking about a physical thing, so negative doesn't make any sense. So b equal to negative 15 doesn't make any sense. So b is 8. Our base is 8 inches. Now we need to take that and plug it into one of our two equations to figure out what the height is. And since the first equation is already solved for the height, we might as well use that to make life easier. So we plug in our 8 for our b, plus 7. 8 plus 7 is 15. And again, our unit is inches. So the height's 15 inches, the base is 8 inches, and that is the end of this video. See you next time.